This is Unpacking Math Standard 1 ATO 6. What do the letters and numbers mean in 1 ATO 6? The 1 means it's a first grade standard. The ATO means this standard is from the key concept of algebraic thinking and operations. And the 6 just means it's the 6th standard in that key concept. Why should we unpack a standard? As a teacher, I have to know what the students have to do to demonstrate proficiency with the standard. So I need to look at the verbs in the standard. The next thing I have to look at is how do they have to do it or demonstrate the standard. So I have to look at what follows the verbs. And then I need to look to see if there's any other information in this standard that I need to know as a teacher in order to teach this standard to its full intent. This is Standard 1 ATO 6. It says to demonstrate A. Addition and subtraction through 20, B. Fluency with addition and subtraction through 10. Where do I go for information to help me unpack this standard? The answer is the South Carolina Unpacking Standards document for math. Where is this unpacking document? We have it linked on our Richland 2 Math Connections Google site. If you go to our Math Connections Google site, you can go to the first grade page for the link. The link takes you directly to a document with pages that look like this one. This is the page for 1 ATO 6, the standard that we're going to unpack. It gives you lots of information that will help you understand the meaning and the depth to this standard, as well as lots of examples. This particular standard has 2 pages so that you can see more examples. When I unpack a standard to go out and work with teachers, I like to get a piece of chart paper and actually write the standard out. I underline the verb and then I try to see what exactly is following the verbs. Then I get out my Post-it notes and I try to put down as many examples as I think I need to understand myself in order to share it with other people. The first part says addition and subtraction through 20. As I look at that one on those 2 pages, it talks about students adding and subtracting. It doesn't talk about counting, but I know that there are 3 levels of the counting strategies which are going to play into this standard. Those levels are further explained in 1 ATO 5, but the strategies are included in Part A of this standard. There are 3 levels of counting strategies. The first one is called Count All. Students that do this always start with 1. So if I gave a kindergartner or an early first grader 3 plus 2, they go 1, 2, 3 on one hand, 1, 2 on the other hand, and then count 1, 2, 3, 4, 5, which means they've started with 1 to count each add-in and the sum. So they've counted those numbers 3 times. In kindergarten, that's where it all starts, so it's fine, but we need to move our children past that, and that's where it happens in first grade. We move them to counting on or counting back, where they're able to hold 1 add-in in their head while counting up, or they're holding a difference in their head to count back. So they'll say 3, 4, 5 to count up, or they might say 5, 4, 3 to count back. But then we move them on to where they make an easier problem by using things like doubles facts and making a 10 to add, or taking from 10 to subtract, or fact families. Let's take the make a 10 strategy, for example, which would be included in this Part A. If we gave the students the problem 9 plus 6, and we were going to let them use counters, we might help them by asking them to make a tower of 9 Unifix cubes and a tower of 6 Unifix cubes. Now, to keep them from going back counting from 1, which many of them want to do, they'll count from 1 all the way up to the answer. But we might say, what number is 9 close to? Some of us call those friendly numbers. And hopefully somebody's going to say 10. So I might ask, so how can I make my 9 turn into a 10? I could move one from the 6 tower over to the 9 tower. That's going to make that an easier problem for me because now I know I have 10 and I have 5 in the other tower, and I learned in kindergarten that 10 and 5 make 15, which is one of my teen numbers. But now let's see if we can connect the concrete manipulative to a picture model. We call that pictorial. Same problem, 9 plus 6. I have 2 empty 10 frames for the students to work on, so they might draw circles to represent 9 in the first 10 frame and X's to represent the 6 in the bottom 10 frame. And I might ask a question again before I let them just start counting from 1. Look at that top 10 frame. What do I notice about it? Well, it's got an empty cell. Wonder what I could do about that. Well, I could take one of those X's at the bottom, circle it, draw an arrow around, and move it up to the empty cell because I know a full 10 frame equals 10. How much does that leave in the bottom 10 frame? Well, I know a full row is 5. 10 and 5 is 15. Think about how that connects to the Unifix cubes. It's the same concept, but now we're just using a picture. Then we move to the abstract, or some books call it symbolic level. Same problem, 9 plus 6. To make a 10 from my 9, because I really don't want somebody drawing 9 sticks and 6 sticks and going back to 1 and counting up, because that's counting all again. I want them to start from that 9, but if they can't, I want them to think, what number is 9 close to? 10. Well, how did I make a 10 before with the 10 frame and the Unifix cubes? Oh, I took a 1 from the 6. So I'm going to take my 6 with my number bond, break it up into 1 and 5. Some books call those break aparts, some call them number bonds, but we know it's when you break apart and find the partners of a number. 9 and 1, I'm going to circle that because that's how I make a 10. I'm going to write 10. That leaves 5. 10 and 5 once again is 15. Connecting back to the 10 frames and the towers. This is how you move from concrete to pictorial to abstract to deepen that concept. The second part says fluency through 10. 10 means that's the highest sum that they're going to have to work with, and all the related addition and subtraction facts within 10. Of course, I want accuracy. But look at these 3 parts of fluency. Other than accuracy, I've got efficiency. Let's look at the definition of efficiency, using the fewest number of steps without resorting to counting. Remember how we were talking about counting from 1 every time? In first grade, we want to move children off of that. So we're hoping that they are moving into those make an easier problem. Maybe they've learned their doubles facts. But if they're still going back to 1 every time, we really can't say that they've reached fluency. Flexibility shows that they know more than one strategy. They might know how to count all, but they might also know doubles. They might also know how to make a 10. So once again, here's my chart, and I want to show you one more thing at the bottom. I drew a little continuum at the bottom because that represents the development of fluency. Children go through these counting and using strategies before becoming fluent with addition and subtraction. And developmentally, they will move at different rates. Be mindful of the different levels so you can give them the tools they need to move forward. You may need to allow some students to continue to use the manipulatives with the pictorial representations until they understand the concept. And remember, this standard is an expectation for the end of first grade.